Now, let's say we have this point here. I'm going to exaggerate a little bit there. I have this graph, and I want the slope at this point, the slope of the tangent line. This is my tangent line. I'm going to use a red marker. I want to find the slope of that line. Now, one way of doing it is you pick a point here too, and you connect these 2 points with the line, and you find the slope of that. And you go, well, you know what, the slope of this line, it's almost the slope of my red line. Well, do they look like the same slope when you look at that picture?
No.
No. Well, let's bring that point closer to this. Let's use that one. What about if I use that point and this point, and I find the slope of them? Does that look like the red line? No, but it's a little bit better than the other one. Let me get closer. That's still not good. Let me get closer right there. And if I connect the 2 points, and notice start to get better and better each time I get closer. So I'm going to again exaggerate the picture here so you get to see what we're doing here. And this was my graph. And let's say these are the 2 points I chose to approximate. This is the tangent line. And I'm using these 2 points. So to find the slope of this line, the black one, if this is x value, let me just take a peek. Yeah, damn it, our book used delta x. If I call the gap between these two as delta x, the gap, then this x value is what? X plus delta x. Isn't it? This, bless you, this point is what? The y value when at x, f of x. And this point is what? F of x plus delta x. That's the y value when x equals to that. You remember the definition of a slope? What's the slope? It's defined as the rise over the run. And the rise here is the change in the 2 y values. What are the 2 y values? That's f of x plus delta x minus f of x. It's this y value minus that y value. And what about the run? The run is what? Isn't that the gap, the distance between these 2 points? And what did we call that distance? Delta x. But there's one more thing I'm going to add to that equation. Notice when I use the 2 points, these 2 points far away, the slope of this line wasn't really close to the slope of the line I'm looking for. So what I need to do is what? Pick 2 points very close to each other. If I pick the points close to each other, the slope, which is the rise over the run, will be the slope of the tangent line. Well, how can I say that? Pick points close to each other. You say that by typing the limit as delta x approaches 0. The gap between the 2 points, you want it to be almost 0. And that will give me the slope of the tangent line. So if you want to find the slope of a tangent line at a point, you need to follow this process. Do the rise over the run, pick 2 points very close to each other. How close? Such that the gap between them is almost zero. The 2 points are right next to each other. If you do the rise over the run, you will have the slope of the tangent line. And if you open any calc book and you look for the definition of derivative, the first thing you see is that equation. So this is what we're going to be talking about in chapter 3. Definition of derivative. Derivative is the slope of the tangent line. That's what the derivative is. But I'm not going to talk about the word derivative yet. I'll stay with the slope of the tangent line. Let's see if that really works or not. Anyone still writing here? I'll wait. So let's take an example. We'll take one simple one that we know the answer to it. Bless you. F of x equals 2x minus 3. Find the slope of the tangent line at what point? At the point 2, 1. In this case, I didn't have actually to do any of the math, any of the work there. Why? Because f of x, that's a straight line, has a y-intercept of what? Negative 3, has a slope of what? 2. It will look like this if you graph it. This is 2x minus 3. What is the slope of this line just by looking at that equation at any point on the line? Better be 2, because that's mx plus b. The slope is 2, the y-intercept is negative 3. But I'm going to use this equation to prove that the slope is going to be 2. So we're saying, what is the slope when x equals to 2? This is x equals to 2. Draw a tangent line. Well, a tangent line for a straight line is going to be the same line. I'll just make it a hair above it so you get to see both lines. That's the tangent line. What is the slope of that line? It better be the same as the other line, which is 2. But the rule says if you want to find the slope at 2, you want to take the limit. M is going to be the limit as delta x approaches 0 of f of x plus delta x minus f of x divided by what? Delta x. I just finished deriving that, saying that right here. And my x here, my point is 2 actually, so this is going to be, because I want to find it at 2, I don't want it at any point. So it's going to be f of 2 plus delta x minus f of 2 divided by delta x. That will give me the slope at 2. If I want the slope at 3, it will be f of 3 plus delta x minus f of 3 divided by delta x. I wanted the slope at 50, becomes f of 50 plus delta x minus f of 50 over delta x. So I need to find the answer to each one of these. What is f of 2 plus delta x? How do we find the answer to that? Replace x in this one with what? 2 plus delta x. Go to this function, replace x with 2 plus delta x. Distribute that, and you will have what? 4 plus 2 delta x minus 3. And what do we have? 1 plus 2 delta x. What is f of 2? Go to the f function, replace x with 2. 4 minus 3, which is what? 1. So you want to find the slope at 2? Because we want it at 2. It's going to be the limit as delta x approaches 0, or you can use h if you don't like delta x. Do we know the answer to f of 2 plus delta x? Which is what? The answer to this piece is right here, 1 plus 2 delta x. Minus, do we know the answer to f of 2? That's a 1. So when you simplify that, what are you going to have? The limit as delta x approaches 0 of 2 times delta x over delta x, and what's going to happen to that delta x's? They will cancel each other out. It becomes the limit of 2 as delta x approaches 0. Direct substitution says every time you see delta x, replace it with 0. You leave the numbers alone. There is no delta x in the answer. The 2 is always a 2. So what's my answer? 2. I knew that before I started the problem, because I knew the tangent line for a straight line is going to be the same line. So the slope of that line is the same thing as the slope of the tangent line, which is a 2. You're not going to get a problem that easy every single time. So a lot of times your problem is not a straight line. So if it's not, you got to follow these 4 steps. Or I don't know how many steps. Write this one. Find f of x plus delta x. Subtract from it, divide by delta x, and take the limit. Let me try another one. Find the slope of the tangent line at, and I'm going to be mean here. Well, not that mean. I'll give you 2 points at 0, 1. I want it twice, and -1, 2. So 2 times I want you to do it. If you graph x squared plus 1, x squared plus 1 is a parabola that looks like this. This is x squared plus 1. I want the slope of the tangent line at 0, 1. This is 0. A tangent line at 0, 1 is a line that touches that point. It's going to look something like this. What do you think the slope of that line just by looking at it?
0.
0. Horizontal line has a 0 slope. So when I find the answer to this one, it better be 0. Negative 1 and 2. That's a point right here. And what's the tangent line of that? It looks like it's coming down. It should be a negative number. I don't know what the answer, but it should be a negative number. The problem is I got to do this twice. And what about if we ask you for another point?
Gotta do it 3 times.
3 times? Well, that sounds like a lot of work for me. So instead of doing the problem twice or 3 times, why not just find an equation for that, for the slope, for any point? And at the end, if you want the answer as 0, you replace 0 for x in that equation. And if you want it at negative 1, you replace x with minus 1. You want it at 2, replace x with 2. So instead of putting numbers and doing the problem twice, you can say, you know what, I'm just going to use x for any value. So the slope at any point, you can use c, you can use x, whatever you want to use, is the limit as delta x approaches 0 of f, instead of, this will be x plus delta x minus f of x divided by delta x. Earlier I said I'm going to use 4 steps. I called this 4-step. Maybe I'll stick with it, the 4-step process I'm going to call it. Actually, that's a good name. So I'm going to use the 4-step process. Why I call it 4-step process? Because in step number 1, it's going to take me 4 steps to get the answer. In step number 1, I need to find f of x plus delta x. That's in the first step. How do you find f of x plus delta x? You go to this problem. You replace x with x plus delta x. If we FOIL this one, multiply it out, this will be x squared. That's why I don't like the delta x. 2x delta x plus delta x squared, there's the 2, plus the 1. The FOIL method. You got to multiply it by itself, not square this and square that. You got to multiply it using the FOIL. That's step number 1. F of x is given to me up here. Can you see it? So I don't have to find it. That was given to me. So step number 2, let me find f of x plus delta x minus f of x. F of x plus delta x is equal to what? X squared plus 2x delta x plus delta x squared plus the 1. Let's subtract from it f of x, which is what? X squared plus 1. And notice the x squared is going to cancel the x squared, and the 1 is going to cancel the 1. What's left there? 2x delta x plus delta x squared. Step number 2 is completed. Step number 3. I'm going to take the answer and divide it by delta x. See that? The answer by delta x. So let's take the answer from step number 2. Now remember, you're dividing each one of these by delta x, not just one of them. So you can't cancel that delta x with this delta x. It's this one divided by delta x, that one divided by delta x. So you're going to end up with what? 2x plus delta x. And what's the last step? Take the limit as delta x approaches 0 of f of x plus delta x minus f of x divided by delta x. That's the limit as delta x approaches 0 of 2x plus delta x. Now replace delta x with 0. What are you going to have? 2x. So what is the slope as a function of x? The slope of the tangent line? It's 2x. Now you tell me where you want it, and I'll give you the answer. Yes?
I have a question on step 3.
Yes.
Can you explain how you got only 2x plus delta x?
Because you got to divide each one of them by delta x. 2x, so if you look at this piece, you can cancel the delta x, right?
Right.
Then you got to divide delta x squared by delta x. There's 2 of them here, and only 1 here. So you still have delta x there.
Thank you.
You're welcome. So you want to find your slope at x equals to 0 now? What's m at 0? Let x be 0. What's 2 times 0? 0. So the slope of this tangent line is 0. We knew that by looking at it. You want to find your slope when x equals minus 1? Let x be minus 1 in the slope. 2 times a negative 1, which is what? Negative 2. We know that slope is negative. It's decreasing. It's coming down. So I can find the slope at any point once I come up with that equation for the slope. So instead of putting 0 here for x and doing the problem and come back again, put a minus 1 for x and minus 1 for x and redo the problem, that's silly. Find it as a function of x. When you get your answer as a function of x, plug in the x value there to get your answer. Especially if you have more than one question. If you only have one, it doesn't matter. You can do what we did before. Just plug in that number. Might even make the math easier. Now, the slope of the tangent line, or this equation, is known as the derivative. I use that word derivative. So let me just say that. So definition of derivative. So we write the derivative of f of x, or if you want f as a function of x, I can do it that write it that way. derivative of f, or f of x, at x is given by the following equation. We use this notation, f bar of x, that's the derivative, which is the limit as delta x approaches 0, f of x plus delta x minus f of x divided by delta x. And what do you know? That was the equation for what? The slope of the tangent line. So the derivative is the slope of the tangent line. I write it down. Is, the derivative is the slope of the tangent line. That's what the derivative is. Now again, some people use our book, other people use a different book. So we have different notation for the derivative. This is a common one, f bar or f prime of x, very popular in almost every calc book. Another one that's very popular in every calc book, they might use this, dy dx. dy. What's the slope? Isn't that delta y over delta x, the change in y over change in x? Well, the reason we use d to mean the points are very close to each other. So that's why the dy dx instead of delta y over delta x. You pick the points close to each other. Very popular notation. You also see y bar. Some books will use y bar if you have y equals. Sometimes you see the problem written like this, d dx. All of these means the same thing. Find the derivative of f of x. And you might even see it looking like this. All of these are the same thing, just different ways of writing it. The first three, extremely popular. Any one of them. These is not often you see. I mean, you see them probably 15-20% of the time. But about 80% of the time you'll see one of these. Doesn't matter which one. So again, when I said dy dx, I said y dy, not delta y. When you see dy dx, what it means really the limit as delta x approaches 0 of delta y over delta x. That's why we use dy. That's what dy dx is. You pick 2 points very close to each other, you do the change in y over the change in x. If you put delta, that doesn't say the points close to each other. By saying dy dx, they're saying make sure the points are very close to each other. So let's go through these and find a few of them, then we'll go home. That's section 3.1. That's all we're doing tonight. Definition of derivative. Here's the question. Find the derivative. Find the derivative of f of x, which is x cubed plus 2x. You know what, actually, let's make it worse. Let's make it x to the 4th even. That's not nice of me. I'm going to use what I call the 4-step process. Step number 1, let me write the definition first before I forget. The definition of derivative. You want to use f prime, you want to use what? F prime of x, because since we have f, might as well use f prime. If I had y, I'll use y prime or dy dx. So f prime of x is equal to the limit as delta x approaches 0, f of x plus delta x minus f of x over delta x. So notice you can have the fanciest calculator you want to have, but it really doesn't help you. If you want to show the steps, the calculator does. It might give you the final answer, but it doesn't show you the steps. So what's step number 1? I need to find f of x plus delta x. And as I said, I'm not being nice tonight. I must be grumpy. Well, I did that on purpose there. Who wants to multiply x plus delta x 4 times?
Not me.
Nobody in the right mind want to multiply it 4 times. So why did I put it there?
Be me.
To remind you to use what? Pascal triangle. Remember Pascal triangle? 1, 1, 1, 2, 1, 1, 1 and 2, 3, 2 and 1, 3, 1, 1, 1 and 3, 4, 3 and 3, 6, 3 and 1, 4, 1 and 1. So to find the answer to this piece, just the first one alone, these are the coefficients I'm going to be using, because that's when n equals 4. So it's going to be, here's the 1, here's the 4, here's the 6, here's the 4, here's the 1, and I need to add to it after that the answer to this, which is what? 2x plus what? 2 delta x. That's this piece. So what's the answer to this?
Wouldn't that'd be minus, wouldn't it?
No, I didn't subtract yet.
Oh.
That's a
Oh,
plus
okay.
here, right? So let's find the answer to this piece. Let me cover the other one. I don't need the other one yet. Let's find the answer to this. So cover this one. Is it covered now? Can you still see it? I want it covered there. And cover this one. I want to find the answer to this one. X plus delta x to the 4th. Pascal triangle says use these numbers. 1, 4, 6, 4, 1. What does that mean? Start with x to what power? 4. Delta x to what power? 0. Plus. Each time after that, what do you want to do? Subtract 1 from this power, add 1 to that power. X squared, delta x squared. X, up. Delta x to what power? 3. And the last one, x to the 0. Delta x to the 4. If you can see that, can you still see it? I had to write small to fit it there. In one step, I did that. Again, if you know these shortcuts, that's why I said your math is going to become much better. I don't know how often you used that before. Probably never. Maybe once. Now you go, wait a minute, I'm not multiplying this 4 times or 5 times. I better learn how to use it. Now let's clean it. And if delta x to the 0 is 1, that's x to the 4th plus 4x cubed delta x plus what? 6x squared delta x squared plus 4x delta x cubed plus delta x to the 4th plus 2x plus 2 delta x. That's step number 1. Wonderful. That's the biggest and toughest step. Step number 2. You want to do f of x plus delta x minus f of x. Well, I know the answer to this. I should have kept it cube. Just will be less writing here. I'm not sure what was I thinking about when I opted to go with 4. Bless you.
Thank you.
Minus f of x. What's f of x? Which is x to the 4th plus 2x. And when you subtract them, x to the 4th cancels x to the 4th, 2x cancels 2x. Here's a little hint. When you finish with step number 2, almost 90% of the time, all your terms should have delta x in them. So notice your answer, they all have delta x in it. Unless you have a crazy problem. But usually all the terms will have delta x in them. That's the result of step number 2. Step number 3, we're going to take the answer. We're almost done with this problem. And divide it by delta x. Take the answer from step number 2. And divided by delta x. Notice that's dividing each one of them by delta x. I'll give you a chance to finish writing. Can you see that in the back there? Or is that writing too small? You can see it? Now let's divide each one by delta x. So cover the rest of them, just look at the first one. If you divide this by delta x, the first one, that delta x will cancel that delta x. What are you going to have left? 4x cubed. Plus, now this is gone, the first one, and the rest of them gone. Divide the second one by delta x. What are you going to have? Yep, 6x squared delta x. Very good. The next one, cover the first two. And the rest of them, divide this by delta x. What do you have left?
4x delta x cubed.
Yep, 4x delta x squared. The next one, you'll have what? Delta x cubed. And the last one is going to be what? 2. I'm dividing every one of them by delta x. Step number 4. Take the limit as delta x approaches 0. F of x plus delta x minus f of x over delta x. That'll be the limit as delta x approaches 0 of this problem. Which means what? Go to this expression, every time you see delta x, take it out and put what? 0. If you replace delta x with 0, what's your final answer? 4x cubed. This piece is 0, it's gone. That piece is 0, that's gone. That piece is 0, that's gone. Plus what? 2. and that is your derivative. That's the slope of the tangent line. You tell me where you want the slope, and I'll tell you what the value of that. You want it at 0, the answer is 2. You want it when x equals 1, the answer is 6. You want it when x equals minus 1, the answer is negative 2. So I can find the slope at any point once I have the equation for the slope, and that's what the derivative is. Yes?
So did you purposely show us like that really long way to do it before you show us the power rule?
What power rule? There's a power rule, there's a shortcut? I don't know about the shortcut. There are actually plenty of shortcuts, yes. The only problem with the shortcuts, sometimes it might not fit. Like we have a specific shortcut for this, this, and that. But if you don't have that, then what do? So really, this is like just like the table with the limit. When everything fails, or if you can't do it, you always go back to the table. You know it's going to work. This will always work. We will show you a shortcut next class that we can get the answer quicker. For this one, I can get the answer in less than 30 seconds. But for other problems, it might not be that easy. So this method, for example, if I said to you, unless you memorize the rule, but I'm going to use this method actually to derive what's the derivative of tangent or secant theta or sine theta. So if we didn't know this process, I couldn't derive that equation for you. So that's why we're looking at that method. The question was, I think there's a shortcut. If you took like AP Calculus in high school somewhere, you know there's a shortcut to all these. You can find the answer much quicker than what we did here. But you're not going to see that till next class. So this section, actually, we're making you doing it the long way. We're not trying to torture you, but you'll see there's an advantage to that. If I'm trying to prove an identity, trying to prove that the derivative tangent is secant, for example. Secant squared, I think they're telling you. Derivative of, yep, tangent, secant squared. Derivative sine of x is cosine of x. Derivative cosine is negative sine. I was thinking about the integral in my head, something stuck about the integral. That's Calc 2. But you're trying to prove these rules, and if you don't know that method here, you can't prove it, you know. Remember, the derivative is what? The slope of the tangent line. There are a few cases where there is no answer to that problem, which means no derivative. Where? If you have a problem that looks like this, and I say, what's the derivative right here? Remember the definition of derivative. Derivative is what? The slope of the tangent line. Well, where is your tangent line? Your tangent line is this line, the vertical line. What is the slope of that line? Undefined. So in a case like this, there is no derivative at that point. Or you might have a problem like this. A v. What's the derivative right here?
0.
Nope. Does not exist. Why? What's the slope from the left side? It's negative slope. What's the slope from the right side? Positive slope. There's no limit. Remember, it's the limit. From the left side, the limit is negative. The limit is positive here. There is no limit. So when you have a problem like this, or you have v's in your actually graph, we have a problem. There is no derivative anytime you have a v shape, because the derivative is the limit. And the limit from the left side have to equal the limit from the right side. The slope from the left has to equal the slope from the right. There is no slope here. It's negative slope. It's positive slope. I don't have a derivative there. And we'll stop with this section.